So now we're asked to graphically depict what the cost volume profit data listed in this problem looks like. So in order to do that, I'm going to pull up Excel here and just show you how we can create a couple of line graphs using the cost equation that we should understand now, given the fixed cost of $64,000 and the variable cost of $4.80 per unit and the sales price of $8 per clock. So if I go into Excel here, and what you'll see is I've created, we'll just call it a table for a better lack of a term here, and I'm going to plot the corresponding revenue and total cost at this expected level of sale, 2,000 units, 4,000 units, and I just picked to go up by an increment of 2,000. So that's kind of my scale here, is 2,000 units per data point that we're going to plot here. So right here I'm going to put how much revenue each clock brings in, which is $8. The variable cost per unit, the problem told us, is $4.80. So I can plot here then my expected revenue at 2,000 units is a function of the quantity times the revenue per unit. My variable cost, which is this column here, I know they're kind of hidden here, I'll unhide those headings for you. The variable cost is going to be the $4.80 times the quantity that we're going to sell, and the fixed cost we said is a constant $64,000, and my total cost is a function of fixed cost plus variable cost. So I can take this formula and drag it all the way down and apply it to each level of sales activity, and it looks like I might have an error here somewhere, since that didn't want to pull down. Let's see if we can do that again. We're going to take the quantity field times the variable cost per unit, and we'll carry this down. Okay, there, it looks like that's working. So now we've got all this data. We can graphically present it here just by inserting a line graph. And so I'm going to put a line graph in to the, I don't know if I can get on here without cutting it all off, but we'll just have to cut off a couple of things. So I'm going to pull up in the data that's going to just draw the graph for me. And I know you can't see all of this on the screen. I'll try to get as much on here as I can. So we're going to add the revenue. So we'll call this series name revenue, and the series value are going to be all of these data points in here down to 21. Okay, so you can see now my revenue has been plotted on here, and now we're also going to plot my total costs. So we're going to add this column here, which are total costs, and we're going to pull it down, and you'll see really quickly here, and I'll edit the x-axis, because right now the x-axis is 1, 2, 3, 4, 9, up to 19. It doesn't really tell me what the unit denominations are. So there you have it. I mean, you can look at the graph here, but you can see how quickly and easy that was to do in Excel as opposed to trying to do it on a piece of paper. And just so you can interpret this correctly, this is the point at which my total cost, which is the orange line, meets my total revenues, which is the blue line. So I break even right here, which is the 20,000 unit part. And so the distance between the 2 points, between the revenue and the total cost, is the profit. So the greater the distance, the more the profit. And down here the opposite is true. The greater the distance, the higher the net loss. So that's how we can interpret that and quickly visually give someone an indication of how that cost volume profit relationship works.